Morning students. Today we will see some further questions. Question number 18 from question number 18 we start today. Question 18, what it says: for what value of lambda the function which is lambda of x square minus 2x and 4x plus 1 is continuous at x equal to 0. And next question, what about the continuity at x equal to 1? This is the question. Now first of all, we discuss the continuity at x equal to 0, and question says for what value of lambda the function is continuous. So yesterday I taught you that what about the meaning continuous at x equal to 0, meaning function is already continuous at x equal to 0 and we have to find the value of lambda. This is a thing. For what value of lambda function is continuous at x equal to 0. So I start my solution right here, since that function is itself continuous as at x equal to 0, it means limit x tends to 0 plus function is equal to limit x tends to 0 minus function is equal to f of 0. All are equal. So any two we have to take such that both should engage. That was yesterday's I taught all these things. Whenever you want to find the value of something, a constant value, both should engage. So this is I have like x less than 0 for left hand limit, x greater than 0 meaning right hand limit. So we want to take these two, so that I'll take here left hand limit and right hand limit. So only taking limit x tends to 0 plus function and limit x tends to 0 minus function. This is enough. Drop that point, because these two, for 0 plus x greater than will come, this function will appear, and for minus it is this function will appear. So it's good enough. Now I'll go with this. Look at limit x tends to 0 plus function is x greater than 0, x 4x plus 1, like that, equal to limit x tends to 0 minus function. So what function will be chosen? X less than 0, meaning lambda into x square minus 2x. Very interesting it is. Now I'll turn as it is in h as usual. So instead of x we will write 0 plus h plus 1 equal to that lambda is a constant value, can be written front side, outside. Instead of x, write limit h tends to 0, turn in h. So instead of x we will write 0 minus h, and instead of x we will write 0 minus h. What about here? When h is going to 0, 4 into 0 plus equal to 0 plus 1 1, and here it is lambda. When h is going to 0, look at properly, h is going to 0, 0 minus 0 into this, 2 into 0. So if you will have the condition which is actually completely nonsense condition, because in that case only lambda actually eliminate itself, lambda is not equal to anything. So this is nonsense here. So I would say that if you will put any value of lambda, function will never be continuous, because it is actually not coming equal for any value of lambda. This is actually false condition. It is coming. We say that it is for all the value of lambda, for no value of lambda, function is continuous. Meaning function cannot be continuous. Why? Because if function will be continuous, definitely we would get lambda something. But even after taking equal to sign, if we are not getting the lambda, meaning we cannot find the value of lambda anytime. So finally I would say for no value of lambda, function is continuous. And what about the next sentence? What about the continuity at x equal to 1? Now it is asking that If function will be continuous, then find the value of lambda. X equal to 1, where x equal to 1. So I would say something very special. X equal to 1 in the sense function described at 0. I would say, look at this is not a very good question to do, but just understanding and the conceptual question. This is a simple number line. I'm saying that the function is defined at 0. Now it is asking about that. What about x equal to 1? Meaning, for what value of lambda if the function is continuous x equal to 1? So x equal to 1 is where? X equal to 1 is this point, which is actually greater than 0. Which is actually greater than 0. So this is x greater than 0, but meaning 4x plus 1. If I take a right hand limit at 1, this function will come. If I take a left hand limit for 1, this function will come. And exactly at x equal to 1, this function will come. Why? Because all that time greater than 0. This is all that time greater than 0. Again, I ask you one thing. This function is defined at 0. And it is asking about x equal to 1. Question says, what about the continuity at x equal to 1? You just have to tell that, is this function continuous at x equal to 1? We check it. We check it. Now we discuss the continuity at x equal to 1. This time we have to check. So okay, I'm taking right hand limit. I ask you one question. What will come? Function. So very simple phenomena that 1 plus, but 1 is not here. So how to see? No matter at all, make a number line. This is 0, this is 1, this is infinity. What is the meaning of 1 plus? X is coming to 1 from the right side. Ultimately x greater than 0, meaning this function 4x plus 1. So I will write 4x plus 1. On changing h, x will turn is 1 plus h plus 1. H is going to 0, 4 plus 1, 5. When I go on the left hand limit, you need not surprise that this time x is coming to 1 from the left direction, meaning x is coming from the left direction, still it is greater than 0, meaning x greater than 0, meaning same function. So I would say you one thing, when I change, you know that answer will be same because function is same. You do by your own, and at x exactly at x equal to 1, one function will be chosen. X equal to 1 is also greater than 0, meaning function is same, 4x plus 1. So f of 1 is equal to again 5 in all sense, meaning it is not depending on lambda, meaning if lambda is equal to 2, no matter at all for this, because left hand limit, right hand limit, main value, all 4x plus 1, which is completely independent for lambda. For the continuity of x at x equal to 1, function is always continuous because it doesn't depend on lambda. At x equal to 1, for right hand limit, for left hand limit, for main value, function is 4x plus 1, which does not depend on lambda. See, even lambda can be put any value, this is same, 4x plus 1, lambda will be 2, this is same, lambda will be 3, this is same. The meaning is what? Lambda can be put any value, but this function is same, so that function will be continuous. So I will write that for all value of lambda, function is continuous. So in the first case, for no value of lambda, because that time lambda was cancelling, lambda was not having with us, that's why we say that for no value of lambda function is continuous. In that case only, it doesn't depend on lambda, so I would say that it is always continuous for any value of lambda. This is enough, I think, to understand you the question. Okay, now we'll move on to the next question. See once or twice this concept, I think you will get it. So let me move on to the next question. What is the next question? Next question is also a bit good because greatest integer function we have explained to you. Question asking about 19th one. Show that function f g of x, I am taking f of x only because it is now practice, x and x. Show that function is discontinuous at all the integer point and only this. Question ask, show that function is discontinuous at all the integer point. That's very simple question. The same concept of greatest integer function I explained just a day before. I think you remember that. How we can show this? Okay, let me explain something. For first making picture, this is very interesting picture. C and C. C is an integer. Suppose I am taking C is an integer. So definitely consecutive integer will be C plus 1. No matter it is plus infinite, no matter it is a minus infinite, but C is an integer I am taking, and C plus 1 will be its consecutive integer. And C minus 1 is definitely just a preceding integer. So this is very simple sequence I have taken just by beginning C as an integer, further integer C plus 1 and back integer C minus 1, because this time I cannot show this proof by taking special any integer, so that I'll take the integer as a constant value like C. C is an integer. So show that function is discontinuous at all the integer. So I'm taking C is an integer. So now read the question. Show that function is discontinuous at C, because C is my integer. So I'll now discuss. I start by working. Let C be any integer, and I start my working it. So we'll show now, and we show the continuity at x equal to C. We check, not so show, we check the continuity at x equal to C. So what to do? You know that right hand limit we take. X tends to C plus function. What is function? Limit x tends to C plus function is x minus greatest integer function. Now change in h. Okay, what is instead of x will come C plus h. This is C plus h. Hope all getting. This is the symbol of simple bracket, but this is not a ordinary bracket. It is a greatest integer function. Okay, now what is the meaning of C plus h? Look at properly. C plus h, you all know. C is this. C plus is just ahead. C plus h. And when this greatest integer function will operate on C plus h, this is similar, but this greatest integer function operate on C plus h, it gives a previous just before nearest integer, which is C. So C plus h having the greatest integer function on C plus h is C. So meaning it will just come C. So C and C will cancel, and definitely h will operate on 0. It gives a 0. So this is limit, right hand limit. So I'll go on a left hand limit. So what is left hand limit? X tends to C minus function. So x tends to C. What is function? X minus integer function x. Now turn in h. So what is instead of x will write C minus h, and this is C minus h. Now what comes after C minus h minus, what is C minus h here? C minus h is just behind C. It is C minus h. And greatest integer function of C minus h is definitely C minus 1, because it is the nearest and less integer. So just C minus 1 will come. Right in bracket. Now definitely when I'll open the bracket, I'll get C minus h minus C plus 1. And I don't want to go slow, because h now going to 0, it is 1. And final condition is it is 0, it is 1. I don't have to go on exactly at x equal to C, because left hand limit itself not coming equal to right hand limit. I would write here, since left hand limit not coming equal to right hand limit, so that function is discontinuous at all integer points, and that's over the question. So hope it is very simple. I think you have got till now, because the condition and concept of greatest integer function we already have seen in early of the lectures, and this is very similar of that. So hope you can make it. Okay, now we'll move on to next question. Next question is 24. Find all the points of discontinuity, and question is sin x upon x if x less than 0. And this is simple question, but we want to do very fast. First of all, which I already have told in the earlier of the lectures, that the continuity, actually we have a infinite point here. Those points which are less than 0 and all the points which are greater than 0. In these intervals, function is always continuous. The question always rises that does function continuous at exactly 0? That is a major question. Look at the thing. This is 0, this is plus infinite, this is minus infinite. Greater than 0, meaning x greater than 0, only a function will come x plus 1. For right hand limit, for left hand limit, for all the value of x which is greater than 0 will be same. When x less than 0 will come, for right hand limit, for left hand limit, function will be same. So that function will be continuous. So we only discuss the continuity at exactly 0. So I would just write here, since function is continuous at all x greater than 0 and x less than 0. So we don't have to find these continuity, but only we discuss the continuity at x equal to 0. And for that we will go for two limits. Limit, right hand limit. Suppose I am taking, this is function. Now choose that what is f of x. So it is x tends to 0 plus, meaning x greater than 0. Let's say x greater than 0, this is x plus 1. X plus 1. So just turn in h. Instead of x, you will write 0 plus h plus 1. And h tends to 0 is give you 1. This is now left hand limit. Limit x tends to 0 minus function. Then definitely x less than 0 will come. Sin x upon x. Intentionally I have actually put this question because this is some of this is a condition, 0 minus h upon 0 minus h. What will come now next? Sine. Look at properly. Sine of minus h upon minus h. Look at the thing. Sine minus theta is equal to minus sine theta. So what I will write? Limit h tends to 0 minus sine h upon minus h. Look at sine minus theta minus sine theta. So both minus will cancel. What remaining? Sine h upon h. And one should know in class 11th you studied, I taught three formulas, main formula for limit. And one of the formula that was x tends to 0, sin x upon x was 1. When x limit for x variable coming. Limit for h variable coming. So it looks very similar. This is even I wrote the formula for x. But this is now applying for h. H tends to 0, sin h upon h itself for 1. So it is none else, it is actually 1. So the limit, right hand limit 1, left hand limit 1, now rest last value. At exactly x equal to 0. It is 0 plus, right hand limit for 0, left hand limit for 0, both have come equal. Now it is at x equal to 0. What is function will come? For x equal to 0, function will come x equal to 0, function will come x plus 1. And when I put exactly value 0 plus 1, again answer is 1. And the last line I think then write that the left hand limit equal to right hand limit equal to main value, meaning function is continuous at x equal to 0. Well, that's all the question I think. So this is again I think a few questions I have told. Tomorrow we will end this particular exercise just by doing some question, and I request you please do try from your side some questions. Okay, thank you.